Hello everyone, let's continue our class. Previously, we learned how to deal with an uneven cash flow series, and we can calculate both future value and present value of those cash flows. And manual calculation is very important for you to understand the mechanism of doing that type of calculation, and also calculator can help you to accomplish the same thing, just that the CF functionality on your BA2 calculator is more complicated for you to get around with. So my suggestion here is do your best to practice more, right? To practice how do you do manual calculation as well as CF functionality on the BA2 calculator. Now let's move on to look at a different type of cash flow problem. That is annuity or annuity due. And annuity is a series of equal payments that occur at regular intervals. If the first payment occurs at the end of each time period, it's called ordinary annuity. If the first payment occurs at the beginning of the period, it's called annuity due. And the perpetuity is a special type of annuity. That is annuity that will last forever. So it's infinite series of equal payment. It's called a perpetuity. And we have three methods to deal with annuity or perpetuities. The first one is apply time value of the money formula. And here you see the formula for calculating present value and the future value of annuities. And the PMT here is the periodic payment, periodic cash flow. And R here is the interest rate, and T is number of time periods. And for perpetuity, it's very simple. You simply take the ratio of periodic payment and the interest rate. And sometimes you want to use your calculator to do the calculation, because calculator can help you to get the right answer more efficiently, and typically you can get the right answer within 30 seconds. Right? And I will teach you how to do calculation on BA2 calculator for annuity and annuity due. And for ordinary annuity, it's pretty straightforward, but for annuity due, you need to know the function of the mode of your calculator. What is the mode of your calculator? The mode of calculator simply specifies when cash flow occurs. There are two modes on your calculator. The first one is default mode, which is the end mode, which means that cash flow occurs at the end of each time period. That is a typical case for annuities and for most finance problems. But sometimes you need to deal with annuity due. Right? Annuity due specifies that cash flow occurs at the beginning of every time period. Calculation is very different, and you need to initiate the beginning mode on your calculator. To initiate beginning mode on your calculator, you need to press second BGM. Where's BGM? BGM is a secondary function for the key of PMT. So when you press second BNG, you will see BGM on the right hand side of your calculator screen. And if you want to change it back to end mode, then you need to do second BGM, second enter, second BGM, second enter. So here's a switch for you to go back and forth between beginning mode and end mode. That is second BGM, second enter. Right? When you do second enter, you are initiating the set function on your calculator, which is secondary function for the key of enter. So remember, To go back and forth between end mode and the beginner mode, you do second payment, second enter, second payment, second enter. And when you need to go back to the end mode, you do the same. Second payment, second enter. Right, second payment means secondary function above PMT, which is a BGM. And second enter means you set the value for your calculator. And here you see the demonstration on how to use spreadsheet to do future value, present value calculation based on annuity or annuity due. And here, if you choose 0, that means ordinary annuity. If you choose 1, that means annuity due. That is the last input for your Excel spreadsheet. And there's a very important issue to remember, which is a matching problem. Right? Matching problem. And sometimes you do calculation on an annual basis, sometimes you do calculation on a quarterly basis or monthly basis. And here you needed to pay attention to the matching, which means when you do annual calculation, the interest rate should be annual rate. If you do monthly calculation, the interest rate should be the monthly rate. And also, your calculator is very sensitive to the direction of cash flow. If it's cash inflows, it carries positive sign. If it's outflow, it carries negative sign. Now, let me introduce the method that we use by doing 5 guys on your calculator. So who are 5 guys? And I think we did this in a previous chapter. 5 guys are 5 keys, 5 buttons on the third row of your BA2 calculator. First one is N, second one is IY, third one is PV, fourth one is PMT, and the last one is FV. So the game on rule here is if you know 4 of those 5 guys, then calculator can help you to capture the 5th one. Right? And then let's say we have annuity problem where you will receive actually, let me see. You deposit 100 each every day and plan to withdraw $20 a year for 5 years, and it asks you what is the future value of that. And here, number of time period is 5, and the interest rate is assumed at 10%. And since you deposit money, therefore the PV is negative 100. Since you are going to withdraw $20 each every year for 5 years, then PMT, this periodic payment, is 20, right? And the future value can be calculated based on 5 guys. Now let's take a look at one example to see how you can utilize 3 different methods to calculate present value of an annuity. Let's say you can afford $632 per month, and the interest rate is 12%, which means monthly rate is 1%. Notice that you are doing monthly calculation. Make sure you pay attention to the matching problem. $632, that is a monthly payment. Therefore, the interest rate should be monthly. And in this case, that is 1%. So here it asks you how much can you borrow? How much can you borrow? If you can afford to pay $632 for each month for the next 48 months or 4 years, then how much can you borrow? And essentially, you're calculating present value of an annuity that has equal payment of $632 for 48 months with a 1% of interest rate. And this is the typical case when you take vehicle loans, when you buy a vehicle, you want to borrow money from the bank, right? And later on, you need to pay monthly payment on your vehicle. And here we can use Five Guys, and Five Guys can help you to get right answer in less than 30 seconds, right? And here you need to find four guys. First one is n, number of time periods, and in this case 48 months or 48. And the IY is the interest rate, which is the monthly rate, that is 1. And PMT, that is periodic payment, monthly payment, should be 632. And what is the future value? Well, in the future you're gonna pay off your vehicle loan, therefore the balance should be 0. So FV should be 0. Then you do compute PV. Your calculator will show you the answer. $23,999.54, or approximately $24,000. Then you can apply the formula to do the same, to fix the same problem. Present value equals monthly payment 632 times 1 minus 1 over 1.1 raised to power 48 divided by 0.01. It will give you the same answer. And also you can use spreadsheet and initiate the function of PV. And 0.01 is the rate, 48 is number of time periods, and the payment is negative 632, because in the future you pay money, that is cash outflows, and the future value is 0. Here's an example showing you how to calculate the present value of annuity. Let's say, suppose you win the Publishers Clearinghouse $10 million sweepstakes, and the money is paid in equal annual install payment of $333,333.33 over the next 30 years. If the discount rate is 5%, it asks you how much is sweepstakes actually worth today. Right? And here you need to calculate the present value of that annuity, which has $333 each every year for the next 30 years. And you can do manual calculation, as you see here, and also you can use your calculator. On your calculator, n equals what? N equals 30, because that's 30 years. What is IY? IY is 5%. You put a 5 as IY. What is PV? Well, you need to calculate PV. And PMT here is 333.33. And FV should equal 0. Then you compute PV to get the exact number that you see here, $5,124,150.29. Now let's take a look at a case where you need to buy a house by taking mortgage loan. Let's say you are ready to buy a house and you have $20,000 for down payment and closing costs. And the closing costs are estimated to be 4% of the loan value. And you have annual salary of $36,000, which means each of the months you take home $3,000. The bank is willing to allow your monthly mortgage payment to be equal to 28% of your monthly income. And the interest rate on the loan is 6% a year, or monthly rate of 0.5%, and you're going to take 30-year fixed rate loan. So the question here is, how much money will the bank loan you, and second, how much can you offer for the house? Well, this is a pretty complicated problem, isn't it? But essentially, you take a loan from the bank that is a current cash flow, that is present value, and in the future you pay back the loan by doing monthly payment, and the monthly payment should be the periodic payment for this annuity. So first of all, let's take a look at how much money that you can afford to pay the monthly payment, and your monthly income is $3,000, and maximum of monthly payment should be 28% of $3,000, which is $840. Since you take 30-year fixed rate mortgage, that means there will be 360 month, right? 360 month as number of time periods, and your interest rate should be 0.5% or 0.5, and the payment is 840. 840. Since you pay money, it carries negative sign, and the future value should be zero. Future value should be zero because in the future you're gonna pay off this mortgage. Then you CPT PV, and the calculator will show you the number is 140 105. 140 105. That is the amount of money that the bank is willing to loan to you, and you also need to pay closing cost on the amount of loan, which equals $5,604, and your down payment should include that closing costs, and the net down payment is $14,396. So the total price that you can afford for this house should be your down payment plus the loan value. Right, $140,000 for the loan and the $14,000 something for your down payment, and the total price should be $154,500. So by doing this calculation, you know very clearly how much you can afford to take a mortgage loan, and also you know what would be the affordable price for a house that you are going to purchase. And essentially we use 5 guys on your calculator to fix an annuity problem. Mortgage loan is a typical annuity problem, but pay attention to the time period. You do calculation on a monthly basis. So the payment is monthly payment, and also the interest rate is the monthly interest rate. Now let's take a quick quiz. Let's say you know the payment amount for a loan and you want to know how much you would borrow. Do you compute the present value or future value? Well, in this case, of course, you do present value because the amount of money that you can borrow will occur at today when you receive a loan from a bank. That is present value, not a future value. Let's do another practice. Let's say you want to receive $5,000 per month in retirement, and you can earn 0.75% per month, and you expect to need income for the next 20 years beyond retirement. How much do you need to have in your account at retirement? Right? And to fix this problem, once again, I want you to draw a timeline. Let's say the retirement year is 0, and you needed to have income for the next 25 years, right? And actually, you need $5,000 a month after retirement. So the time period should be 25, and the monthly payment should be $5,000, right? And in 25 years, there will be 300 months. So on this timeline, you see a series of 300 cash flows, and each cash flow has an amount of $5,000. So this is annuity problem. And on your calculator, you set n, number of time periods is 300. That means 300 months, and IY 0.75 or 0.75 monthly interest rate, and the PMT, periodic payment, 5,000, and FV is 0. Suppose that you're going to spend all your money after 25 years. Then you compute PV, and the PV should be negative $595,808 and $11. So in this case, in your 401k retirement plan, you probably need something close to $600,000, right, in order to have $5,000 per month revenue for your post-retirement life, assuming that you will live for another 25 years. And you can fix the same problem by using Excel spreadsheet. Here, The first number is rate of the interest, which is 0.0075. Be careful about this small number, right? 0.75% equals 0.0075. And the second number is number of time periods, 300 months. PMT is 5,000, and the FV is 0. So here's more examples. Let's say you want to borrow $20,000 for a new car, and you can borrow at 8% per year, compound monthly. So monthly interest rate should be 0.6667%. If you take 4-year loan, what would be your monthly payment? Previously, we used the 5 guys to calculate PV. Now, knowing the PV, we can calculate monthly payment. Right? And on your calculator, you set 48 as N, 0.6667 as IY, which is the monthly interest rate, and the PV is money that you will receive from the bank for your new car, which is $20,000, and FV0, which means you pay off your vehicle loan, and then you compute your monthly payment, or PMT, and your calculator will show negative 488.26. That means your monthly payment should be something around $500 for this new car. And you can do the same calculation by using Excel spreadsheet. Here's another example. Let's say you have $1,000 due on credit card, and the payment is $20 monthly minimum, and rate the interest rate is 1.5% a month, 1.5% a month, and it asks you how many years does it take for you to pay off that $1,000 balance. So the balance here is $1,000. It's positive because that is money that you borrowed from credit card company. And your payment would be negative 20 because in the future you're gonna pay that amount of money that is negative, right? And IY here is the monthly interest, the 1.5, and the future value 0 means you pay off this credit card balance. And knowing those 4 guys, you can fix the 5th one, which is number of time periods. And essentially, it will show you the number of months that you need to pay off this $1,000 balance based on your minimum payment on your credit card. When you compute N, you will see 983,111. That means 93.1 months, which can be translated into a little less than 8 years. So even for a small amount of balance on credit card, if you use monthly minimum payment, it takes a long time for you to pay off. The longer the time that you borrow money from a credit card company is gonna charge you more interest. Remember that. And also you can use MPER function on your Excel to fix the same problem, and MPER means number of period. And once you get that number, remember that is number of months, not number of years. And if you need a number for years, you need to do the conversion, right? Number of months divided by 12 to get number of years. Suppose you borrowed $2,000 at 5%, you are going to make annual payment of $734.42. It asks you how long before you can pay off the loan, and here you do similar calculation to compute N, right? And the inputs are IY 5, PV 2,000, and PMT negative $734.42. Right? Sometimes you may forget that negative sign, but I think it's okay because when you do CPTN, your calculator will show arrow 5. Arrow 5 means you missed a negative sign. So here you need to be very clear about the direction of cash flow. Put a negative sign on PMT. Here's more examples. Suppose you borrow $10,000 from your parents to buy a car. You agree to pay $207.58 per month for 60 months. It asks you what is the monthly interest rate, and here you know number of time periods, 60, PV, the amount of money that you borrowed, $10,000, and your monthly payment would be $207.58. Future value should be 0. Then you compute IY, that is monthly interest rate. Look, Five Guys are a very convenient tool for you to fix any variables such as unknown interest rate, unknown payment, present value, number of years, so on and so forth. So the game rule here is once you capture 4 of those 5 guys, you can fix the 5th one. It's a very convenient method. You can get the right answer within 30 seconds once you identify those 4 guys. Here's a quick quiz question. You want to receive $5,000 per month for the next 5 years. How much would you need to deposit today if you can earn 0.75% per month? Right, per month. Once again, this is monthly calculation. And the number of months 60, IY 0.75, payment 5,000, that is deposit because you are going to receive, and FV0. Then you compute PV, and the answer is negative 248.66.87. So essentially, you need to deposit nearly $250,000 in order to receive $5,000 per month for the next 5 years. Right. And in the previous case, you also know that, okay, under a reasonable interest rate, if you want to receive $5,000 monthly income post-retirement, you need more than $500,000, right? It's something around $600,000 to support 25 years of post-retirement life with the $5,000 monthly income. So remember, saving is very important for your future retirement, and it takes time for your money to grow in your retirement plan or investment plan. You need to save and invest for your future. Second quiz. You want to receive $5,000 per month for the next 5 years, and what monthly rate would you need to earn if you only have $2,000 to deposit? So if you have less money to deposit, but you're expecting the same amount of money for your retirement spending, then the only way to achieve that is to have higher rate of return for your investment, or higher interest rate. And here you do 60M, negative 200,000 PV, 5,000 PMT, 0 FV, and when you compute IY, it will show you 1.4395% per month. Right? Is that easy number to achieve? The answer is no. Why? Monthly rate of 1.4 means annual rate would be something around 16-17%. Right? And on the financial market, it's easy for you to make 5, 6, 7%. It's getting more and more challenging when you needed to achieve anything beyond 10%. If you invest in stock market to bear a lot of risk, you can make something around 11%, but 16-17% is a really challenging goal to achieve. Right? So if you cannot save enough, then you have to invest to earn higher return, but getting higher return is much harder. And so for most people, if they want to have more money to spend after retirement, the best solution is to save more. Suppose you have $2,000 to deposit and can earn 0.75% per month, and how many months could you receive $5,000 payment? So it asks you to give certain amount of balance in your retirement plan and a reasonable interest rate. It asks you how long your retirement plan can support your retirement life, post-retirement life. And here you essentially calculate N. N is the 5th guy, and here you need to find the 4 other guys. IY 0.75, PV negative 200,000, and PMT 5,000, FV0. So here number of months is 47.73. Some people say, hey, 48 years. No, that is number of months. It's about 4 years. It's only about 4 years. So typically, if you have $200,000 left in your retirement plan with a reasonable interest rate, it can only support 4, maybe 5 years of your post-retirement life. So if you want to live longer, you need to save more. And here's another question. Suppose you have $200,000 deposit and can earn 0.5% per month. How much could you receive each every month for 5 years? So here you calculate PMT, giving you no N, IY, PV, and FV. Now let's take a look at, previously we calculated present value of annuity, and sometimes you need to calculate future value for annuity. Here's an example. Suppose you begin saving for your retirement by depositing $2,000 per year in an IRA. IRA means individual investment account. If the interest rate is 7.5%, how much will you have in 40 years? In 40 years. So essentially it's asking you what would be the outcome of your savings, and here you're going to save for 40 years and 40. Interest rate 7.5, that is IY. PV, what is PV? You didn't see any number for PV. PV 0. Currently you have nothing, right? And but good thing will happen because you begin to save each every month. And payment here is negative 2,000. That means you pay $2,000 each every month and put it into your retirement plan. Then you compute FV. Right? Once you press FV, you will see a large number. $454,000. $454,000. Right? And you start small, $2,000 a year. Right? Everybody can do that. But if you can do it consistently for a long time period, it can generate some great numbers, such as $454,000. Previously, you know that, okay, to have a good life for your retirement, let's say you're going to have enough money for the next 25 years after your retirement, you probably need $600,000, right? How to get that $600,000? And here you see a feasible way to achieve that. You need to save for a long time period, 40 years, maybe 30 years at least. And each every year you save $2,000 in this case, and if you want to get more, you need to save more. Let's take a look at how we can deal with annuity due problem by doing second payment, second enter. Right? And let's say you are saving for a new house. You put $10,000 per year in an account, paying 8%. The first payment is made today, and it asks you how much will you have at the end of 3 years. So here, the payment happens at beginning of each every time period because the first payment is made today. So here we need to do annuity due calculation, right? To deal with annuity due, you needed to change the mode of your calculator from default setting of end mode to beginning mode. Right? To get to the beginning mode, you do second PMT, second enter. Second PMT, second enter. Essentially, you are utilizing the beginning function and the set function. Both beginning set function and second function for PMT button and enter button. Once you do second payment, second enter, your calculator will show BGN. BGN means beginning mode. When you see BGN, you know that your calculator is on the beginning mode. Remember, after you complete annuity due problem, you needed to convert your calculator from beginning mode back to the end mode. So don't forget to do the same operation. Second payment, second enter when you finish annuity due problem solving. And right now you see BGN on your calculator. Then you enter 3N, 3 years, 8 IY, 8% interest rate. PV is 0, and your payment is negative 10,000. 10,000 negative because it's cash outflow. Then you compute FV. It will show $35,061.12. So don't forget to reset your calculator to the N mode by doing second payment, second enter. So here's a summary of the method that we can utilize to fix annuity and perpetuity and annuity due. For perpetuity, perpetuity is annuity that will last forever. That's annuity that will last forever. And the value of the present value perpetuity equals periodic payment divided by the interest rate. Interest rate is a very easy calculation. And later on you will know that preferred stock is pretty much like perpetuity. And the value of preferred stock equals preferred stock dividend divided by its interest rate. It's a very easy calculation. And here's another quiz question. You want to have $1 million to use for retirement in 35 years, and if you can earn 1% per month, how much do you need to deposit on a monthly basis if the first payment is made in 1 month? So here you need to calculate monthly payment, or PMT, on your calculator. And four other guys are, first one, N. What is N? 35 years. Is that 35? No. We do calculation on monthly basis. It should be 35 times 12, which is a 420 month. That is M. What is IY? Well, since you do monthly calculation, the interest rate should be monthly interest rate, which is a 1% And the PV is 0 in this case, because you want to have 1 million to use in the future. Right now you have nothing. It's okay. PV equals 0, but FV here should be 1 million. FV should be 1 million. It carries positive sign because you are going to have that 1 million in the future. It's cash inflow. Then you compute PMT. And the PMT is negative 155.5. Alright. Here you got a little surprise. It looks like 1 million is a lot of money, but to get that 1 million, you only needed to save $155.50 each every month. If the annual rate of return is about 12% a year or 1% per month, right? So everybody can become a millionaire in the future, but you have to save consistently for a long time period. And here you need to save for 35 years. And also your return is about 12%. Is 12% harder to achieve? I would say no. If you invest in stock market for the long term, your return is gonna be something around 11-12%. Right? And here each every month you save $155. Right? And let's say your return is about 12% each every month, each every year, no month, 1% a month, 12% a year. Then you will get that $1 million 35 years later. Right? So long-term saving can generate a large amount of money for your future. Don't forget about that. So start save today and save for that 1 million for your future retirement. Now, let's take a look at another question. You want to have 1 million to use for retirement in 35 years, and then you can 1% per month. How much do you need to deposit on a monthly basis if the first payment is made today? Well, it looks like the same problem, but here it's annuity due because first payment is going to be made today at the beginning of first month. So here you do beginning mode, second payment, second enter. Make sure you see BGN on your calculator, then you do the same operation. When you do CPT payment, then you will see negative 153.96. That is the monthly payment they need to make to get the $1 million if you decide to deposit money at the beginning of every month. At the end of this question, don't forget to go back to the N mode by pressing second payment, second enter. You're considering to purchase a preferred stock that pays quarterly dividend of $1.50. If your desired rate of return is 3% per quarter, then how much will you be willing to pay for that? Well, this is the perpetuity problem. And the answer is very simple to find. That is the ratio of dividend or cash flow, $1.5 divided by interest rate of 3%, which will generate $50 results. Now, let's take a look at a very important issue associated with the quoted interest rate. When you need to borrow a house, when you need to take a mortgage loan to buy a house, when you need to borrow money from car dealers, often so the professional will give you the quote for the interest rate, and you typically will get a terminology called APR, or annual percentage rate, and people view that as the true measurement of the interest rate, but actually it is not. It's the nominal rate of interest for your mortgage loan or your vehicle loan, and your true interest rate is very likely a little greater than that APR. If you need to know the true interest rate, you need to do a little extra work to figure out what EAR is. EAR means effective annual rate. Effective annual rate. So what is the trick? The trick here is compounding assumption. And you view APR as the true rate of interest because you assume that the compounding of money happens on the annual basis. If that assumption is valid, then APR should equal to EAR. However, in most cases, the compounding cycle is not one for a year. As a matter of fact, you can ask any mortgage lender across the country, what is the compounding period for each year? The typical answer is 365 days, which means money is compounded on the daily basis. Money is compounded on the daily basis. When money is compounded on the daily basis, what does that mean? Well, if money is compounded on a daily basis, then you're going to pay more interest to the bankers, right? And if money is compounded on an annual basis, you pay less. That's the trick. So in most cases, this EAR is greater than APR depending on the compounding cycle, right? And the typical compounding cycle is on the daily basis, or 365 days a year. And to understand your true interest rate or effective annual rate, you need to pay attention to the matching problem once again, the matching of time periods with interest rate. Annual rate should match annual rate. Annual period should match annual rate, and monthly period should match monthly rate. And here's a relationship between true interest rate, EAR, or effective annual rate, with APR, the quoted interest rate in most mortgage contracts. Right? And EAR equals 1 plus APR divided by M, raised power M, minus 1. And this APR is quoted rate, and this EAR is effective annual rate, or the true interest rate. So EAR would be higher if this M is greater. M is number of compounding on the annual basis. If it's compounded on the daily basis, then this M is going to be 365. If it's compounded on a monthly basis, then this M is 12. If it's compounded on the quarterly basis, then this M would be 4. Although there's an automatic function that you can utilize on a calculator to figure out ER and APR, I do not recommend you to utilize it. And I think this formula is a very straightforward way for you to figure out either EAR or APR. Now let's take a look at one example. Which savings account would you choose? 5.25 with daily compounding or 5.3% with semi-annual compounding? So here you needed to, both 5.25% and 5.3% are nominal rate or APR. So the key here is to calculate effective annual rate or EAR. And for the daily compounding, this ER equals 1 plus APR 0.525 divided by number of compounding in a year, which is 365. Then you raise power 365 or minus 1 to get 5.39%. So that is the true interest rate based on daily compounding. And then you do the calculation for the second account. The APR is 0.053 and the compounding is twice a year because it's semi-annual compounding. And then you raise power 2 for that item and or minus 1 to get 5.37%. Right? So without asking how money is compounded, you would say, hey, second account has higher interest rate, 5.3% versus 5.25% for the first account. But your true interest rate actually is higher. Your true interest rate is higher for the first account with the daily compounding. So when you need to deal with the mortgage banker, make sure you understand daily compounding mechanism. Make sure you understand the true interest rate for your mortgage loan. Right? And remember, your interest is calculated based on daily compounding so that bankers can maximize their revenue. And here's more issues associated with computing APR. So APR can be calculated based on monthly rate or semi-annual rate, and you simply multiply the rate with number of months or number of semi-annual time periods. And here's demonstration using calculator to figure out EAR and APR, but I think it's not necessary, and I think the formula is very straightforward way for you to figure out EAR based on APR or APR based on EAR. And if you want to figure out APR, then here is the equation that can utilize 1 plus EAR with power 1 over m minus 1 and time that number with m to get APR. Is just the opposite formula of the first equation that you see here. EAR equals 1 plus APR divided by m, and always power of m minus 1. Now here's more examples, and you will see more examples in your homework, and make sure you do multiple practice to familiar with the calculational mechanism. Now let's look at the last topic that we're going to discuss before we conclude this chapter. That is amortization for loan. And when you get a mortgage loan from a banker, you needed to pay monthly payment, equal amount of monthly payment in the future. But with in every monthly payment, you know that the interest payment and the principal payments are very different every month. In the early months or early years, you pay more for interests. In the later years, you pay more for the principal. Why is that? Because in early years, you have less money that you use to pay down the principal. Right? In that case, your interest is the major part of your monthly payment. In the later years, since your principal has been paid, I mean, the most part of principal has been paid, therefore the interest amount will decline to lower level. So you pay more money for principal reduction than interest payment. So although monthly payments are equal amount, but the amount of interest payment and the principal payment is very different for different amounts. So here's one example. Right, let's say we have 4-year loan with annual payment and interest is 8%. Principal amount is $5,000. The first question is, what is the annual payment? So this is a pretty easy problem to tackle. You simply compute a PMT based on M4, IY8, 5,000 PV, and a 0 PV, and it will show you monthly payment. Your annual payment would be $1,500 or something. Also, and here is the table showing you the amortization schedule for this 4-year loan. Right, for this 4-year loan, your yearly payment is $15,960. Right, for each every year, it's the same amount. It's the same amount, but within each every payment, you will see different amount for interest and principal payments. And for your first year payment, you pay $1,509.60. Guess what? Your principal payment is $1,100 and your interest payment is $400. How do you get those two numbers? Well, you do a little bit calculation. The interest payment should equal to beginning balance times the interest rate. Your beginning balance $5,000. Interest is 8%, therefore interest paid for first year is $400, and the rest should be the principal payment. And after the first year, your balance is lower. Ending balance is lower, $3,890, and so the interest that you are going to pay for second year would be less, which is $311.23. And the principal, since you pay less for interest, the money will go into your principal payment, and your principal payment goes up to $1,198.37 for the second year. And the same thing continues for third year and fourth year. And from the table, you see that interest paid is declining. It's declining over years from $400 in the first year all the way down to $111 for the fourth year. Meanwhile, your principal payment increased gradually from $1,100 to nearly $1,400 in the fourth year. And this table showed you so-called mortgage amortization, mortgage loan amortization table. It essentially showed you the different interest payment and the principal payment for each every time period. Right, so this is a very important chapter, and in this chapter we learned how to deal with uneven cash flow problems by calculating future value and present value. Now we can do manual calculation, and I require you to do the practice to manually solve uneven cash flow problem for both future value and present value. And also you need to know how to use your calculator's CF function to fix uneven cash flow problem as well. And for annuity, you need to know how to use that 5 guys, helping you to fix PV, N, IY, PMT, so on and so forth. It's very convenient. And giving you no 4 guys, you can capture the 5th one, right? No matter it's present value or future value for annuity. And the perpetuity is annuity that will last forever, and the calculation is very simple. And for annuity due, you need to change the mode of your calculator. Right? Sometimes it's virtually impossible for you to do manual calculation. You have to use your calculator for annuity due problems, such as, for example, if you need to calculate number of time periods for annuity due, then you have to use your calculator. And before you do any calculation, you need to change the mode of your calculator from end mode to beginning mode if you are going to fix an annuity due problem. Right? That's what we learned in this chapter, and I hope you enjoyed this lecture, and I will see you in the next one. Thank you.